This one is an assignment for you to watch this video. I'm going to go through this slide really quick because it is basically the same idea that we covered. You're going to be doing LSTMs. You're going to be using CRF. You have a sentence. You want to do named entity recognition. This is a person. That's a person. These are all others. This is a location. This is miscellaneous. This is actually the beginning of miscellaneous. This is the middle of or inside a miscellaneous. And then you are merging the two as a post-processing step. Or this could be your actual ground truth data. A sequence goes in. A sequence is going to come out. You are going to have a matrix of scores. These are the scores coming out of your architecture, which could be LSTMs. These A's, if they are 0, you are working with the independent assumption that the tag of the first word is different from the tag of is independent, is totally independent from the tag of the word next to it, which is not such a great assumption. You can relax that assumption and bring in some sort of compatibility score or dependence versus independence using a matrix A, which has the size of your tags plus 2, because you have some spatial tags, the beginning of your sentence, the end of your sentence. You can write down your softmax over all of the possible tags. This is going to end up being a huge space. It's not easy to actually evaluate this probability, let alone optimize it multiple times. Therefore, you're going to use some dynamic programming procedures to reduce the cost of evaluating this. So far, so good. This we actually covered today in the previous slide. What is the contribution here? And this is exactly what I mentioned. Documents are formed by sentences. Sentences are formed by a sequence of words. We can even go at a lower level. Words are created by sequences of characters. And then you can have your character, for instance, for the word Mars. It's a character sequence. You can have a forward LSTM, backward LSTM, concatenate them, and that's going to give you an embedding for the word Mars. This embedding is formed from the characters. You can form the embedding the usual way using lookup tables and embedding matrices. You can concatenate them, and that's going to give you your final embedding. So the only thing that's different from this paper and the previous one is this additional step. And you're going to see the improvement. Any questions about neural architectures? Okay, perfect.